Okay guys, so welcome back to another video. So today we're going to be looking at rather an interesting problem. So these types of problems are speed, distance, time, but they're also quadratic. So I was really stumbled upon these problems, so that's what I'll be teaching you guys today. So let's understand the question first. The distance between two towns is 80 kilometers by road and 90 kilometers by rail. A car takes 15 minutes longer than a train, whose average speed is 8 kilometers greater than the car's average speed. Okay, so just from the information that I've just read, I'm able to understand that the car is traveling on the 80-kilometer road and the rail is taking the 90-kilometer path. So let's write scenario 1. Scenario 1. So under scenario 1, let's write distance, speed and time. Okay, and let's write scenario 2 here, and the same distance, speed and time. Okay, so to do these types of questions, we need to first be able to understand the distance, speed, time triangle, DST. I'm pretty sure you all know this already. You can cover time to, if you want to find time, you can do distance over speed. If you want to do speed, you can do distance over time. And if you want to do distance, you can do speed times time. That's just the DST triangle. Makes it easier to understand. Okay, so getting back to our question. In the second sentence, they're telling us a car takes 15 minutes longer than a train. Okay, so we are able to understand that the car is going to be the slower option. So the rail is going to finish this race faster. And yeah, let's just plot everything we know into these two tables. So for scenario 1, which is the car, we're able to understand that the distance traveled is 80 kilometers. Okay? Then the speed that they're traveling at is x. Let's label it as x. Let the speed be x. X kilometers per hour. And then the time that it takes, if you follow the DST triangle, is distance over speed, which is 80 over x hours. Okay, so that's a scenario 1 filled out. Now let's do the same with scenario 2. Our distance we know is 90 kilometers. Then we know the speed. So now the speed here is x, yeah. Let's keep that x. But they're saying that average speed is x. Average speed is 8 kilometers greater than the car's. So if the car's speed is x, it's x plus 8 kilometers per hour. Exactly. So then our time would reflect accordingly to 90 over x plus 8. Right. So now let's dig into these problems. If we look at, they're asking us to find the average speed of the car and the train. So I guess that's what the result of our end quadratic will be. Right. So we know this. So, oh wait, they've also given us one extra information. The fact that the car, we haven't used this yet, the car takes 15 minutes longer than a train. Right? Well, we'll put that into use. So they're telling us that the car takes 15 minutes longer than the train. So, from here, let's formulate this, right? Follow me. Follow me here. 80 over x, so scenario 1, minus, okay, minus 90 over x plus 8. So we're just subtracting the time like we did by scenario 1 by the scenario 2 time. That must equal to, well, 15 minutes, right? But then because we're all calculating in kilometers per hour, let's turn this into hours, which is 15 over 60. which can be simplified down to 1 over 4. Okay, so if you rewrite this, it's 80 over x minus 90 over x plus 8 is equal to 1 over 4. So now on the left hand side, let's find a common denominator and subtract. So if we let x plus 8 be the common denominator here, let's write it again. 80 over x minus 90 over x plus 8. So here if we let x plus 8 be the common denominator, and let's let x be the common denominator here. So it's 90x and then 80 into x plus 8. So putting this into the calculator, you should be getting 80x plus 80 into 8 gives us 640 over, here it's, let's just leave it at x plus 8. Okay, that, and then minus, we have 90x here, right? That whole thing's equal to 1 over 4. Beautiful. So excuse me, sorry, my voice got a little dry there. Right, so from this stage we can simplify further. 80x minus 90x is minus 10x plus 640 over x plus 8 is equal to 1 over 4. Now yeah, I don't think we can simplify any further, so it's a matter of cross multiplying, right? So 4 and minus 10x plus 640 is equal to x plus 8. So expanding the brackets, we got minus 40x plus, sorry, it's not a plus, it's a minus. So what's 4 into 640? So that's minus 2560. That's equal to x squared plus 8x, right? Bringing everything to the right hand side, we get x squared plus 8x minus 40x, sorry, plus 40x plus 2560 is equal to 0. So now that gives us, what do you call, x squared plus 48x plus 2560 is equal to 0. And now punching this into your calculator by doing the what? My bad. Punching this, you can either go ahead with the factorization method, although that is extremely difficult here. Let's try. What's 60 and... No, actually in second hand, you can't really do the factorization method. It's extremely difficult here. So let's just use the quadratic formula here. So we know the quadratic formula is minus 48 plus minus root 48 squared minus 4 1, and then says 2560 whole thing over 2. So now this will give x as two potential candidates, which is x is equal to 32 or x is equal to minus 80. Okay, now if you think about it logically, in these types of problems, x cannot equal to a negative number, hence we can strike this out. Yeah, I know that looks ugly, but we can strike that out and determine x to be 32. If x is equal to 32, which is the length of the car, then what is the train? Well, we know that the train is equal to x plus 8. So 32 plus 8 is equal to 40 kilometers per hour. So The car traveled at 32 kilometers an hour, and the train traveled at 40 kilometers per hour. Well, thanks for watching and have a great day.